Hi everyone, and welcome back to the lab. In this video, I'll be generating acetic anhydride using the ketene lamp method. Before I begin, I really need to stress the danger of this procedure. Absolutely do not try this at home. Most university labs won't let you try this. And here's why. If you look, these are the IDLH values for several compounds here. That's the immediately dangerous to life and health as established by a government agency whose job it is to set workplace threshold standards for a lot of compounds. Now, these aren't the safe thresholds. These are the immediately dangerous to life and health thresholds. This is causing damage type threshold. And you can see for hydrogen cyanide, it's 50 parts per million. For phosgene, it's only 2 parts per million. And for ketene, which is what we'll be generating, of course, is 5 parts per million. 10 times more toxic than hydrogen cyanide by animal study. So, if that gives you any indication of how extremely toxic this stuff is, if it does escape, that should be it. So yeah, long story short, don't do this unless you know exactly what you are doing. All right, let's go. So today I'll be making a compound called ketene, which is the standard nomenclature is ethenone, but it's commonly called ketene. Now, unfortunately, ketenes are also a class of compounds which just have this sort of structure here, basically ketone, which is right next to a double bond there. So you get a ketone-ene, right? So anyway, ketene itself, though, is commonly referred to as this compound here, and it's pretty easily made by the pyrolysis of acetone. So this is acetone here, and with some heat, that's about 500 or 600 degrees C, you end up with ketene and methane. Of course, this needs to be done in an environment where there's no oxygen present, otherwise it'll just burn up. So pyrolyze the acetone, you end up with methane and ketene. The ketene itself is highly reactive, as you can probably see by its structure there, and it reacts with water very easily to form acetic acid. In fact, it acetylates a lot of things. So basically, you're just acetylating the water or hydrolyzing the ketene, whichever way you want to look at it, to form the acetic acid. Anyway, it'll also react with acetic acid to form acetic anhydride, which is the compound that we're after. I've tried to manufacture acetic anhydride directly from water by starting to bubble the ketene directly into water to form the acetic acid, and then once it becomes 100% acetic acid, then the conversion to acetic anhydride is quickly followed thereafter. Unfortunately, it doesn't quite work that way. There are enough side reactions with the acetone and the pyrolysis and things like that you end up with about 70% acetic acid before absorption of the ketene into the solution completely stops. And I've been ascertaining this by weight. I've been running this generator pretty much all week trying to figure out a good way to do this. So essentially, you can start with either glacial acetic acid and go directly to acetic anhydride very quickly, or you can go from water and go to about 70% acetic acid very quickly. But at that point, the acetic acid will have to be taken out and fractionally distilled to get pure acetic acid to start again with this step. It has to be separated somewhere in between, because otherwise there are too many side reactions and you end up polymerizing everything beyond that. So anyway, I've set up a generator to do this, as you might have seen in a previous video. I've got it all set up now, so let's go have a look at it, and we'll make some acetic anhydride. So this monstrous piece of apparatus is the ketene generator itself. As outlined, if you want to look it up, it's in I believe Vogel's Organic Chem textbook. It's pretty much the exact same setup with a few modifications. Of course, the ketene lamp isn't quite the same, but it does work just as well. So essentially there's a heating mantle here which refluxes acetone. That is acetone. Those are degradation products from the filament and the copper wires. I'll get into that in a second. So that's acetone. It refluxes up through this chromatography column bulb and then into this Claisen adapter up here where it hits this condenser, and it falls all the way back down. Now in the middle here, of course, it has to pass this filament, and this filament is heated quite hot to about red heat, which in Fahrenheit is like 1500. That's probably like maybe 600 or 700 Celsius. Anyway, these electrodes here supply the filament with power, and you can see how I built that in the previous video. And the power is supplied by this variac. And I've found for the length of nichrome I'm using, 40-ish volts works just fine. It's a 20 amp variac, so I'm not really worried about burning anything out. Anyway, the acetone is of course returned by the reflux condenser here, but the ketene, having a much lower boiling point, and same thing with the methane, passes the condenser and ends up here. And it travels down this grand condenser here, which is a really efficient condenser, and this is to strip any remaining bits of acetone vapor and stuff like that out. And you can see it does collect some pyrolysis products of diketene and things like that. Ketene is actually photosensitive, so you kind of want to run this out of direct sunlight, otherwise you'll end up with a lot more pyrolysis products than than normal. Anyway, the finishing condenser strips out any of the heavier impurities, and so you're left with nothing but the ketene and methane coming out this tube here, where it gets bubbled into a flask of whatever you want, which is not shown here, of course, but will, in a short period of time, be acetic acid. So anyway, I'm going to set this up. The first thing to do is to get the acetone refluxing, because of course you can't turn the filament on without blowing everything up unless you have this entire thing filled with acetone vapor. Very, very important, right? Because there's oxygen in there now. So I'll turn on the heating mantle here, and we'll get the acetone refluxing, and I'll get set up with some glacial acetic acid in the container there, and we'll go ahead and generate some acetic anhydride. The acetone is now refluxing happily. You can see it running down the walls of the flask here and dripping from the reflux condenser. And that means that the generator is ready to go. All you do is turn on the filament. But first we'll set up the absorption flask over here. I've weighed out 30.9 grams of commercial glacial acetic acid, which is sort of essential for reasons I've mentioned before, how starting from water is kind of a pain unless you do a distillation in the middle, but I showed how to make acetic acid before, so we'll start with glacial acetic acid. It's at 30.9 grams, and this should absorb ketene until it weighs 52.5 grams, at which point it will be purely acetic anhydride. So get the absorption here. Just get the tube down in the flask, and the excess will vent out the top, as with the methane and everything, and just be pulled out by the hood. And again, toxicity is extreme with this stuff, so really, this has got to be extremely carefully monitored. A smoke test is always a good idea as well. If you have like a smoke bomb or something like that, just put it on the bench, and if you get any smoke in the room rather than going straight out the hood, then you need to reevaluate the setup. Alright, so there we go. We're all set to go. I just need to turn on the filament. And when I do so, you'll see that bubbles will immediately begin to form. But I'll focus on the filament really fast so you can see it heat up. I'll get the lights dimmed here. Alright, filament in 3, 2, 1, power. And there you go. You can see it's happily glowing a dull red color. It shows it more purple on the camera because the camera picks up a lot of IR. But yeah, there you go. So it looks like in the light, not that bright. And we are generating ketene now. So it's time for me to get out of here and get some PPE and stuff. So anyway, we'll let that bubble until it's gained the correct amount of weight. Well, here we are about 80 minutes later. I've shut down the reactor. It's still bubbling down. And you can see that the flask has gained substantial volume, and it's also quite warm as the reaction of acetic acid with ketene has taken place. Anyway, I'm going to weigh this flask, and we'll figure out how much it weighs, and see that the conversion to acetic anhydride is substantial. I've been weighing it every 20 minutes or so. It's been 80 minutes, like I said, and this has gained almost exactly the correct amount of weight. So we can do some presumptive tests for acetic anhydride and call it a day. To show that the product is acetic anhydride, I've prepared 3 tubes here, each with some distilled water in them. And in one tube, I'm going to place some commercial acetic anhydride. We'll see how it behaves when it reacts with the water. I'll also put some glacial acetic acid, again, commercial, in this tube over here, since that's what we started with. And then in the middle tube, I'll place some of the product that we just made, and we'll note how that behaves and see how it compares to those two. Although I can say from running this generator all week that this is substantially pure acetic anhydride. So first anhydride to the water, and you can see it goes straight to the bottom and sort of layers out. See it down there? Now acetic anhydride doesn't hydrolyze that rapidly in cold water, so you can see it'll actually form a separate layer, but that after about 10 minutes will have gone away. Reacted with the water, of course, to form acetic acid, as all anhydrides do. They react with water to go back to the acid state. Now if we go to the acetic acid, I'll type at a similar amount to there, you can see immediately that it just mixes with it. There's no extra state, no globs, nothing. It just mixed right in. So if this is acetic acid still, it should mix. If it's a portion of acetic acid, a portion of it should mix. And if it's acetic anhydride, it shouldn't mix at all. So let's do a presumptive test here. There we go. And as you can see, it's shot straight to the bottom in little globs. And now there's a blob on the bottom. Showing that is substantially pure acetic anhydride. And in fact, like I said from earlier in the week, distillation has proved that. I've gone ahead and run this through a fractionating column to see if I can strip any acetic acid out of it. But there really wasn't much in there. So, and it gained like 101.4% of the weight that it should gain to be fully converted, which makes sense because this is 99.7% acetic acid. So anyway, works out really well. It's kind of a dangerous process, but if you need acetic anhydride, there you go. Anyway, I hope you enjoyed this video. I certainly enjoyed making it, and of course now I have a whole bunch of acetic anhydride that I need to do something with, and I hope to make a cool video with it. But anyway, I have a new Patreon account. I'll link it in the description below. I know some of you have mentioned, asked me for a Patreon account so you could donate, which I didn't really think about before, but I think is probably a really good idea. I can use it to, buy apparatus and labware and stuff and keep giving you guys these cool videos. So anyway, if you feel like donating, have at it. I really appreciate it if you do. And yeah, if you want to leave a comment, let me know. I'll see if I can respond. And as always, like and subscribe.